Hi everyone, this video is for section 7.3, double angle identities. In this particular problem, we want to rewrite the expression without exponents attached to it. So this is kind of like a puzzle game. One of the first things that I'm going to do is, I want to note that I have some power reduction identities that I could consult. So I'm going to go ahead and rewrite them in red over here in the corner. One particular one that I'm looking at is the sine squared of alpha is equal to 1 minus the cosine of 2 alpha all over 2. Okay. So from here, oh, and then I also do have, we might need this one as well. The cosine squared of alpha is equal to the cosine of 2 alpha plus 1 all over 2. So I'm going to keep those identities on hand. So one of the first things that I'm going to note here for my particular problem here, I have sine of 3x to the 4th power. I'm going to rewrite it so that I can actually use those identities that I'm seeing over there. So I'm just going to say, well, isn't the sine of 3x to the 4th power the same as the sine squared of 3x, that whole thing squared? So basically, I undid my power rule from what I have learned about exponents. So what I'm going to go ahead and do now is I can use this power reduction identity. So on the inside, I'm going to get 1 minus the cosine of 2 times 3x all over 2, and that whole thing is being squared. Okay, so this is helpful, but now I'm going to go ahead and expand this out. Okay, so basically what I'm saying is I'm going to have 1 minus the cosine of 6x all over 2 times itself. So I'm basically just expanding out that exponent. Okay, I'm going to scoot that up. Okay. So if we were to go ahead and do this, I'm going to FOIL it out. I'm not going to do the full-blown FOIL. I'm just going to skip to that end step. So if you want to, please go ahead and pause the video and do the foiling to double check to make sure that you have that skill down. But if I FOIL this out, because I'm going to have to FOIL out the numerator, I'm going to get 1 minus 2 times the cosine of 6x, so there's my middle term, plus cosine squared of 6x all over 4. Okay, so this is a little bit of strategy of what I'm going to do next. This may not have necessarily been intuitive as you're looking at this, but what I'm going to do is I'm going to actually take this out of the shorthand. So how I have each of my terms over a 4, each of my terms, I'm going to write it so that it's under a 4. So I'm going to remove it from that shorthand. So I have 1/4 minus 2 times the cosine of 6x all over 4 plus the cosine squared of 6x all over 4. So the reason why I did that is basically I'm going to help prevent myself from getting a headache. So I'm going to scoot this up. And actually what we should notice here is I can use my other power reduction rule here now. So, sorry, I moved prematurely. So let's go ahead and rewrite this problem now. So we have 1/4 minus, we can reduce this down. So this is the cosine of 6x all over 2 plus we have the cosine of 2 times 6x plus 1 all over 2. And this is all over 4. So we have a complex fraction that we're going to have to deal with and clean up. So if we need to, or if you feel the need, let's do a quick aside here to clean it up. So this is the cosine of, we'll just say 12x now, plus 1. We'll take care of that multiplication inside the trig function. and we're going to divide it by 4. So this becomes, remember, we skip the first fraction, we flip the other, and that gives us a multiplication problem. So really what we have here is we have 1/4 minus the cosine of 6x over 2 plus, now I can rewrite this from what I have from my aside. So this is going to give me the cosine of 12x plus 1 all over 8. But note, I do have 2 terms here. So again, I'm going to break that shorthand that I'm seeing. So this is going to give me 1/4 minus the cosine of 6x divided by 2 plus the cosine of 12x all over 8 plus 1/8. The reason why I'm doing that is because I can combine these two values. So if I wanted to rewrite this 1/4 plus 1/8, I'm doing another aside. That's the same thing as 2/8 plus 1/8, which will give me 3/8. So we'll go ahead and we will combine that. So we have 3/8 minus the cosine of 6x minus 2, or sorry, all over 2, plus the cosine of 12x all over 8. And as you can see, we've rewritten the problem so that there are no exponents in our final solution.